Hello, Math 10 scholars. This is Mr. Sutton, and today we are going to be talking about scientific notation. What is scientific notation? Scientific notation is a more convenient way to express extremely large or small numbers. So you want to make sure you have your notes out, and I want you to write down this for scientific notation. Scientific notation is a more convenient way to express extremely large or small numbers. So how does it work? Let's say that we have a really large number like 75 million. So instead of writing out 75 with 6 zeros after it, to convert it to scientific notation, what they do is they move the decimal point all the way up here right after the first digit. So we would say 7.5. But we want to keep these things equal, right? 75 million is not the same as 7.5. So we have to say it's 7.5 multiplied by something to make it equal to that. So what you would have to multiply 7.5 by in order to make it equal to 75 million is 10 million. And you can check that in your calculator. 7.5 times 10 million equals 75 million. Now this here still isn't very simple, right? This seems just as hard, if not harder to write than 75 million. But when we have a number like this, where it's just one with a bunch of zeros, there's a really easy way we can write that. And so I'm going to say 7.5 times, and we could write that as 10 to some power. And in this case, it would be 10 to the 7th power. Now, an easy way to figure that out is you just count the number of zeros. There's 7 zeros. So 7.5 times 10 to the 7th power. Same thing as 75 million. And this is just a little bit easier to write. This is our scientific notation. And what's nice about the scientific notation is you really just have to look at the 7.5 right here, and then you just have to look at this number up here, and what that tells you is how far you have to move that decimal place to the right or to the left. All right, so I see 7.5, so then I know it's going to be a 7 and a 5, and then 6 zeros after it, just off of that 7 right there. Okay, so we're going to take a look at some examples with this. So first we're going to take a look at converting from scientific notation to standard. So here we have just a 6 times 10 to the 5th power. So there's nothing after the decimal place, so we can go ahead and say that there's 5 zeros, right? It'll be same as 6 with 5 zeros. 1, 2, 3, 4, 5. We would move this decimal place right here 5 places to the right. So that would be 600,000. Okay. And if you're not sure about that, you can work the whole thing out, right? You can say 6 times, and then what is 10 to the 5th power? That's 100,000. So when you multiply 6 times 100,000, it's 600,000. But the easy way to do this, and the reason why we use scientific notation, why it's easy, is because I can look at the 6 and I can look at the 5, and I know what this means is a 6 with 5 zeros after it. That is what is nice about scientific notation. So you can check yourself by working the whole thing out, but it's nice to have this shorthand. So now let's go ahead and think about this next one. This one's a little different than what we've looked at because we have a negative exponent right here. So if we think about the negative exponent, what that means, I would have 3.4 and then times 10 to the negative fourth is the same as 0.0001. So if we were to multiply those together, what you would get is 0.00034. And the shorthand here works exactly the same. Again, you don't need to write out these steps because what this 10 to the negative fourth means is that I'm moving this decimal point right here 4 places to the left this time. Up here, we moved it 5 to the right because it's a positive number. Now, since it's a negative number, I know I'm moving this decimal place 4 places to the right. So we could think about it this way. We could say 3.4 and then 1, 2, 3, 4. The decimal place is going to go here. And I just fill these in with the zeros. I'm going to put a 0 in front. So this is our answer. 0.00034. Okay. We can use that same shorthand to go the other way. So the first thing we want to think about is where we want the decimal place to go. So we want it to go right after the first digit. So we would say 6.4 and then times 10. That has to be there. And then we want to think about how many places we moved that decimal point to figure out what this exponent needs to be. So it was right here, and we moved it all the way up here. So we moved it 6 places. Okay, so think about it the other way, it would be 6, and then the 4 with 5 zeros after it to make the full 6 places. And we can do the same thing for the extremely small numbers. We do want to move that decimal place right after the first non-zero digit. So you would say 6.5. And then we still want to say times 10. And then for the exponent, we just want to think about how many places we moved the decimal point. And this time, since we're talking about an extremely small number, it's going to be a negative exponent. And so that would be 1, 2, 3, 4 decimal places. All right. Now we're going to think about multiplying and dividing in scientific notation. Now this relates pretty heavily to our exponent rules that we learn about in algebra. So the first thing I think I would do here is it says, what is the product of 630 and 7.2 times 10 to the 4 power expressed in scientific notation? Now we could convert these both to numbers and then multiply them together and then convert that final result into a scientific notation. But I think since scientific notation, since we know our exponent rules, I think it's easier to work these out in scientific notation. So what I'm going to do is I'm going to convert this 630 to scientific notation first. So I'm going to say, even though that's not a very big number, I'm still going to say 6.3 times 10, and that'll be to the second power. And then we're multiplying this by, because this is the product, so we're multiplying this by 7.2 times 10 to the fourth. Now remember, you can multiply numbers in any order. So what I'm going to do is I'm going to go ahead and group the 6.3 and the 7.2 together. I'm going to say those multiplied together times 10 to the second power times 10 to the fourth power. And the reason I'm doing it this way is because our exponent rules can help us 10 to the second power times 10 to the fourth power. Remember, when you are multiplying, like, let's say we have x to the fifth times x to the second. Remember, our exponent rules tell us we just add these exponents together. That's the same as x times x times x times x times x 5 times, and then multiply 2 more times, right? So we would just get x to the 7. So we can do that same, we can apply that same logic to what we have with these tens. So really what we have here is we have 2 tens multiplied by each other times 4 more tens multiplied by each other. So we can add those exponents. Really, this is 6 tens all being multiplied together. And then the 6.3 times the 7.2. I'm going to go ahead and pull out my calculator for that one. 6.3 times 7.2 is 45.36. Now notice this is not quite in scientific notation. We do have to have that decimal point over here, so we got to move that. So that is 4.536 times 10. And since I moved that decimal place over to the left, I need to add another 10 here. So that is times 10 to the 7th. And then down here we have what is the quotient of 1.728 times 10 to the 9th and 4.8 times 10 to the 6th expressed in scientific notation. Notice here this time it says quotient, which means we are dividing these things. And so I would, again, if it's not already both of these terms in scientific notation, I would go ahead and put those in scientific notation. So we have the quotient of 1.728 times 10 to the 9th over 4.8 times 10 to the 6th. Once again, I would go ahead and think about these things separately. 1.728 over 4.8. And over here, we could have our tens, 10 to the 9th over 10 to the 6th. I would go ahead and separate the fraction like that, because these tens, just like we did before, we can use our exponent rules. This would be like 10 multiplied by itself 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9 over 10 multiplied by itself 6 times. 1, 2, 3, 4, 5, 6. So a lot of these 10s will cancel, right? And we're just left with 3 10s. And if you remember your exponent rules, then you already knew that you can just subtract these. 9 minus 6 is 3. So we know we're going to have times 10 to the third power. So now we just have to think about what 1.728 divided by 4.8 is. I'm going to go ahead and use my calculator again. 1.728 divided by 4.8 is 0.36. And once again, we do need to move that decimal place. Go this way. So 3.6, the decimal place has to be after the first non-zero digit for it to be true scientific notation. So 3.6 times 10 to the second now, because we already moved that decimal place once, so now we would only have to move it 2 more times in order to get our true results. So this right here is our final answer in scientific notation. So there are some rules that we can apply for multiplying and dividing in scientific notation, so that we don't necessarily have to go through all of those steps, and the rules are when you're multiplying, and make sure you write these down, you want to multiply the coefficients and then add the exponents. So just like we did in this first problem, we multiplied the coefficients, the 6.3, the 7.2, and then we added the exponents. We added 2 and 4, we got 6. And don't forget the final step to convert it. You do need to make sure that the decimal place is after the first digit. So multiply the coefficients, then add the exponents. And then to divide, you want to divide the coefficients, then subtract the exponents. So just like we did in this example, we had the coefficients 1.728 and 4.8. We divided those, we got the 0.36, and then we had our exponents and we subtracted them. 9 minus 6 is 3. And then we converted. So you might want to add another rule. Make sure the decimal is after the first non-zero digits. Right, that is the end of the video. If you have any questions, please make sure you write those down in your notes so you are ready to ask those when you get to class. And if you have me, I will see you in class. Otherwise, have a good day.